try to cover. Good evening, everyone. For our first session, we will try to cover up on the topic of triangles. And in our syllabus, the first thing we cover is the congruency of triangles. Before doing the congruency of triangles, we have to know what congruency is. So simply, congruency is like being similar. If you consider two triangles, or if you consider any two objects, even if it's a irregular object, something like this. If we can overlap another object with this object, we can say that the two objects are congruent. Now, in our syllabus, the congruency we learn is for plane figures, 2D figures. For example, a square or a rectangle or any other shape we can draw in this whiteboard, we can consider them as plane figures. Now, when we come to the topic of congruency of triangles, or when we consider congruent triangles, there are few cases we should learn for triangles to be congruent or similar. We can use 4 cases, and even if one of those cases are true, we can say that the two triangles are congruent. So let's take the first case. Case number 1. The first case is the case in which two adjacent sides and the included angle between those sides, and the included angle between the two sides to be equal. Or in short form, we can say that the case is S. S stands for side and A stands for angle. So if we consider two triangles, let one triangle be ABC and the other triangle PQR. If they have given that as data, if they have given that AC side is equal to PQ side and BC side is equal to QR side, then also if this angle over here, angle ACB, is equal to angle PQR. Now there are 3 elements which are equal in this triangle. Side AC is equal to PQ and side BC is equal to QR. Here in this case, one side and another side of the other triangle is equal. One side BC of the first triangle and QR of the other triangle is equal. And the included angle, here is ACB angle, and over here it's PQR angle. If those 3 elements are equal, here the triangles are congruent. Triangle ABC is congruent with triangle PQR, considering this case, side angle side case. This is the symbol we use to show congruency, just 3 lines. The symbol over here indicates congruency, similar to equal. There's another line to show that any two figures or any two objects are congruent. That is the first case. Now, there are 3 other more cases. If we consider case number 2 or the second case, the second case is the magnitudes of two angles, and the length of a side. And the length of a side being equal. Length of a side of the triangle being equal to the other triangles, two angles and a side of the and a corresponding side of the other triangle. It's short for AAS, angle, side. As earlier, we can consider two triangles. Let's consider the first triangle as ABC and the other triangle as P, Q, and R. If this angle over here and this angle over here is equal, let's consider the angles as theta. If angle BAC is equal to angle QRT, and if this angle over here, angle ABC, is equal to angle PQR. Now, two angles, two elements of the two triangles are equal. And if we consider another side, if it's this side over here, for the triangles to be congruent, it should be equal to this side over here. Now, when considering the side over here, for the triangles to be congruent, BC here is the angle in front of angle BAC, or the angle in front of theta. Similarly, if we consider the other triangle, for the triangles to be congruent, if they are congruent, this side over here, for the case to be true, the length of the corresponding side, or the corresponding side, should be the angle in front of the equal angle of the earlier triangle. So, if BC is equal to PQ, or the angle in front of theta, here, the angle in front of QRP, then these two triangles are equal. Similarly, even if these two are equal, the angle in front of the side in front of the angle alpha, here it's AC and here it's PR, then again the two triangles are congruent by the case AAS. Also, if these two are equal, then again these two triangles can be congruent. So, if these two are equal, and if the angle in front of each relevant angle, so if this side is equal to this side, then these two triangles are equal. If not, if these two sides are equal, then again the triangles are equal. Or if this angle, or if this side over here, the side in front of the remaining angle, if those two sides are equal, then again these two triangles are congruent by the case AAS. And the third case, which is a simple case, it's S, S, and S. Simply, it's the case where the three sides of the triangles are equal. The three sides of the triangle are equal. So we consider triangle ABC and PQR. If AB is equal to PQ and if BC is equal to QR and if AC is equal to PR, then these two triangles are congruent. That's the most simple case. Now, someone might think if it's AA, if the three angles are equal, won't the triangle be congruent? No. If the three angles are equal, I mean not each angle in each triangle, like if corresponding angles are equal between the two triangles, then the triangles won't be congruent, the triangles will be equivalent. Now, think of it like this. We consider equilateral triangle where all the angles are 60. You can consider a larger equilateral triangle as well, right? Here, the three angles are equal. This angle is equal to this is equal to this, and this is equal to this. But these two triangles are not congruent, they are equivalent. When the angles are same in two triangles, the triangles are not congruent, they are equivalent. Now, for the fourth case, we discussed the third case. The third case is SSS. So if we summarize the cases until now, the first case it's SAS. One side of one triangle, two sides of two adjacent sides of the triangle, and the included angle being equal. The second case, AAs. Two angles of the triangles and a corresponding side to be equal. And SSS for the three sides of the triangles, to be equal. And the fourth case it's a special case because the triangle should be of a type here to be safe. The fourth case is discussed only for right angle triangles. The fourth case is discussed only for right angle triangles. The fourth case is the case of the hypotenuse and the side of a right angle triangle being equal and the side of another of a right angle triangle. So the fourth case is we consider two triangles like this. If these two triangles are congruent, in this case, if this side and this side, and if the hypotenuse is equal, like the hypotenuse should be equal and another side of the two remaining sides should be equal, then these two triangles are congruent as well. Now this is possible only for right angle triangles or triangles which contain a 90-degree angle. Their hypotenuse should be equal and either these two can be equal or even these two can be equal. Either way, if the hypotenuses are equal and another side, the right angle triangle is equal, then these two triangles can be considered congruent. For example, if the hypotenuse here is 5 centimeters and if the side here is 2.5. If the side here is 2.5, then these two triangles are congruent. Or even if this is 2.5, these two triangles are congruent. The hypotenuse should be equal and either of the sides should be equal. Then the triangles are congruent. This is special for right angle triangles. As a short term for the fourth case, we can say it's RHS. Right angle, hypotenuse, and the side. So to cover up the congruency, we can do some exercises. If you have your textbook, the grade 10 part 1 textbook and turn to page 62, you find your miscellaneous exercises. Now if I can discuss those exercises. Miscellaneous exercise. So we can discuss the miscellaneous exercises on page number 62 of your grade 10 part 1 book. Question number 1. They have given a figure. Show the figure. As data, they have given that in the figure AX is parallel to YB. AX is parallel to YB and AX is equal to YB as well. They have given that these two sides are equal and parallel. The notation according to Euler notation is AX is parallel to YB and AX is equal to YB. This is the data they have given. They have asked us to show that the straight lines AB and YX bisect each other at P. Now, what do you mean by bisect? If these two lines bisect each other, that means we should show that AB is equal to PB and that PY is equal to PX. That is what we must show. Bisecting means if we consider a line, that bisecting a line means that you divide the two lines by half or at a ratio of 1 to 1. It's like passing a line through the midpoint of another line. So the line is divided in two, or it's bisected. The term bi means two. Sect means like sectioning. So bisect means dividing something into two. So how can we do this? Now, if if in this case we somehow prove that these two triangles are congruent, if we prove that the triangles AXP and if we prove that the triangles AXP and PBY are congruent, if we prove this, then ultimately this side and this side, the sides AP and BP and the sides PY and PX are equal, right? By their congruency. So what we can do is we can consider the other elements which are equal using the data they have given. Now, if we consider the figure here, and if we consider the fact that these two lines are parallel, we can say that this angle over here is equal to this angle over here. What is the case for it? The case for it is alternate angles. Alternate angles are when two sides are parallel, and if we draw a line joining them in any manner, this angle over here is equal to this angle over here. We name these two angles as alternate angles. They are of the same magnitude. Similarly, we consider this angle is equal to this angle over here. These two are also alternate angles. Now, here, angle AXP is equal to angle BY PY as alternate angles. Now, if you're equalizing something or if you're writing some type of information or data, you have to mention the reason with it as well. You have to give a reason for your statements. So the reason here is alternate angles. This is the symbol we use for angles. And similarly, you can consider this angle over here, angle PAX. Angle PAX is equal to angle PBY. The same reason, alternate angles. Now, using the four cases, what are the four cases? The first case is SAS, the next it's AAS, two angles and a corresponding side. The third is three sides, SSS, and the fourth RHS, which is a special condition only for right angle triangles. Here we can use this case over here. AS, two angles and corresponding sides. Now, if these two angles and this side is equal, this side and this side over this side and the side over here is equal, you can't use this case because the corresponding side is the side in front of the specific angle. Now, in front of this angle over here, it's this side. And similarly, this is the remaining angle. When you consider the two angles, you consider these two angles here. So the remaining angle is this angle over here, and the side in front of this angle should be equal to the remaining angles side in the next triangles. Should be equal to the side of the remaining angle in the other triangle as well. So the remaining angle here is BPY. When these two sides are equal, you can use the case AAS. Now, using that, it's given as data. You can name these two triangles as congruent triangles. Triangle AXP is congruent with triangle BYP. Condition AAS. Therefore, by their congruency, you can say that AP is equal to PDP. The reason congruent triangles. Congruent triangles. Similarly, this side PX is equal to PY. The same reason congruent triangles. So, using these two facts, the fact that AP is equal to BP and the fact that PX is equal to PY, you can say that the sides or the lines AB and YX bisect each other at P. Question number 2. We draw the figure given. As data they have given in the triangle ABC, the midpoint of AC is M. So they have stated that the midpoint of AC is M, so therefore AM is equal to CM. The perpendiculars drawn from A meet BM at P, and the perpendiculars and BM is produced at P and Q respectively. So BM is elongated to meet at Q. The perpendicular drawn from C to BQ, or this line over here, the extended BM line, meets at Q. Show that the triangles A and P is not given in the question, but it's given in the figure. Show that the triangle A and P is congruent to triangle NQC. They have asked us to show that this triangle over here is congruent with this triangle over here. Now, in this case, by just looking at the figure, you can say that two elements are equal, right? The right angles are present and their hypotenuse, not their hypotenuses over here, because yes, their hypotenuses are also equal. This side is equal to this side, and this angle, these two angles are also equal, right? So, what's the most probable case you can use? The most probable case you might think is the fourth one, right? Angle, hypotenuse, and side. No. Here you can use another theory as well. Here, we consider these angles over here. They are equal, right? What's the case for it? They are vertically opposite angles. What are vertically opposite angles? We consider two lines which intersect each other if you consider the opposite angles, or either these two angles are equal, and if you consider this pair, this is also equal. This is known as vertically opposite angles. Now for a proof, you can say that you can consider this. What's the total angle over here? It's 180. So if this angle here is theta, here it's 180 minus theta, 180 degrees minus theta. So here if this angle is theta, this angle here should be 180 minus theta, right? Now if you consider this straight line over here, this total angle is 180, so definitely this angle here should be theta. And these two angles should be equal. So by vertically opposite angles, angle AMP should be equal to angle AMP is equal to angle CNQ. Right? So also, as given in the figure, angle APM is equal to angle CQM, which is both where both are equal to 90 degrees. Then also as a fact, they have given in the question as data. The reason here is vertically opposite angles, vertically opposite angles. Here it's data. Also as data, they have given that AM is equal to MC, data. Now corresponding sides are equal. Here is the hyperneuse, here is the hyperneuse as well. And these two angles are equal. You can use the case AAS here as well. Two angles and a corresponding side is equal. So the triangles AMP is congruent to triangle CMQ by AAS. Question number 3. They are given as a diagram here as well. And in the diagram, they have represented all the data we should consider. Using the information in the figure, show that triangle ADF, this triangle over here, is congruent with this triangle over here, DBE. Now, as a data, they have given that these two sides are equal. Now, let's consider how to prove that these two sides or these two triangles are congruent. Considering BFCE, As a fact, they have given that DF is parallel to EC. And also they have given that FC is parallel to DE. CF is parallel to DE. If opposite sides are parallel, EE, let's consider CEDF. CEDF is a parallelogram. When opposite sides are parallel, CDEF is a parallelogram. This side is parallel to this side, and this side is parallel to this side. Then definitely CEDF is a parallelogram. If CEDF is a parallelogram, then opposite sides should be equal. Then, therefore, this is the symbol we use for the word therefore. It's a mathematical symbol. Therefore, EE is equal to FC. But we have to consider these two triangles, right? So how can we use this? Without considering sides here, it's better if we can consider angles here. Here, if you consider this angle over here, we consider this angle over here. You can say that it is equal to the angle ACB. And if you consider this angle over here, it's equal to the angle you find over here. Similarly, if you consider this angle, it's equal to the angle over here. Just using alternate angles, you can prove all of this. Now, we consider the first angle I considered. We consider the angle DEB. It's equal to angle EDF. It's equal to angle EDF. Because these two sides are parallel, then these two angles are alternate. And as DFCE is a parallelogram or CEDF is a parallelogram, their opposite angles should be equal. Then angle EDF is equal to angle ECF. Right? Similarly, if you consider this angle over here, or if you consider now, you can consider this angle over here. If you consider the angle AFD, AFD is also equal to angle EDF. You don't have to consider this angle over here. You can consider these two alternate angles. Then again, you can consider these two alternate angles. By using those two facts, you can say that these two angles are equal. Angle EDF is an alternate angle with angle AFD. For both the facts, the reason is alternate angles. Now, as they are alternate angles, these two angles are equal. Now, in these two triangles, as data they have given that two elements are equal. BD and AD are equal, it's a data. We have found that these two angles are equal. Another element is equal. So far, we have one angle. And an angle pair and a side pair as equal. Now, we can't use the fact SA is now here because the side they have given is the side in front of the angles. So definitely the case here we should use is AAS. Then we should find another angle where they are equal. So if you consider this angle over here, we consider this angle over here, these two are equal now. Definitely we should prove that these two angles are equal. Right? Now how do we prove that this angle is equal to this angle? There are several ways. If you consider this angle as theta, this here is theta, then it's theta as well. You don't get this line. If you consider this angle as alpha, the angle over here is alpha as well, as they are alternate angles. These two are parallel sides, even though this is elongated, still these two lines are parallel. Then this angle here is alpha, and if you consider this angle as alpha, this angle over here is alpha as well. So definitely this angle is alpha by the theory of vertically opposite angles. These two lines are intersected, these two are opposite angles, then this angle is alpha. Then angle DBE is equal to angle ADF. Now two angles and the corresponding side are equal. So the triangle ABF is congruent with triangle DBE by the case of AAS. Two angles and a corresponding side are equal. Question number 4. ABC in the figure is equilateral triangle. The midpoints of AC and AB are E and F respectively. So they have given a triangle, an equilateral triangle, ABC. And the midpoints of AB, AC and AB are respectively E and F. So then asked us to show that AB and FC are perpendicular. Then asked us to show that AB and FC are perpendicular. So in order to show that those two lines are perpendicular, this angle over here, or either this angle over here should be 90. We should prove that these two angles are 90. So what can we do? We know that these angles are 60 degrees because it's an equilateral triangle. In an equilateral triangle, all three angles are 60 degrees. And again, if we consider, as they are given that these angles are equal, these sides are equal, now as it's an equilateral triangle, the side AB is equal to the side AC, and these are midpoints, so all four of these sides are equal. Here, if we consider these angles, by theory, if the line which bisects another line in the triangle from the vertex in front of that angle. Now, if the line drawn from this vertex over here bisects this line, that line bisects the angle as well. So, these angles are now half of 6 is 30. If the line drawn from this vertex over here bisects the line in front of it, this line bisects the angle as well, the angle at that vertex of that triangle. Similarly, the same case here, this line bisects this angle, so these two angles are 30, half of 60. Now, if these two are, if this angle is 30 and this whole thing is 60, this angle here should be 90. The sum of interior angles of the triangle add up to 180 degrees. So this angle is 90. Similarly, this angle is 90 as well. If those are 90, then FC is parallel to AB and BE is parallel to AC. Now to show the last case that CF is equal to B, we can consider by showing that these two triangles, CBF and BCE being congruent. How can we say that those two are congruent? By the given data, we have found that BF is equal to AC and that these two angles are equal, right? These two angles are 90. Angle BFC is equal to angle BEC equal to 90 and sides BF is equal to BC. BC is common to both. BC is common. And also, BC is the hypotenuse of both the triangles. BC is the hypotenuse of triangles BCE and BCF. So, these two triangles are congruent by the case RHS. Hypotenuse. It's common to both. Two sides are equal, two angles are equal. So, triangle BCE is congruent with triangle BCF by RHS. So, then by the congruency of triangles, we can say that this side is equal to this side over here. CF is equal to the side DE. CF equals to the side DE. Question number 5. They have given that these two sides are equal and that these two sides are equal. So by that data itself, we can say that triangle ABC is isosceles triangle. And that triangle BDC is also, or BCD is also an isosceles triangle. So from those facts, we can say that angle ABC is equal, as ABC is isosceles triangle, angle ABC is equal to angle ACB. Similarly, angle CBB is equal to angle BCD, as triangle BCD is isosceles triangle. Now, if we consider this angle as theta and this angle as alpha, if we consider this whole angle as theta and this small angle as alpha, this angle over here is theta minus alpha. Similarly, here it's theta minus alpha. Angle, therefore, angles BAB is equal to angles BCD is equal to theta minus alpha. Right? Now, here from that case, we can say that the triangles ABB and ACD are congruent by the case SAS, side, angle, side. The included angles are equal. So, triangles BAB is congruent with triangles BCB by the case of SAS. BA equals AB equals AC data. BB equals CD data. Then these two triangles are congruent. Then what have they asked us to prove? They have asked us to prove that the triangles ABD and CAD are congruent. We have proved that. I'm sorry, not BAB. Here is BAB. Here it's not BCD. Here is this triangle over here. BCD is this whole triangle, not BCD. It's angle BAB. Sorry, it's angle ABB. Here it's ACD. It's equal to theta minus alpha. Then triangles ABD or BAB. Sorry, it's ABD. And triangle CAD. Yes, CAD. Are equal. Not equal, they are congruent by the case of SAS. Next, they have asked us to prove that the triangle BAE is congruent with CA. BA is congruent with CA. So how can we do that? By this congruence itself, we can say that these angles are equal. Right? By this congruence, we can say that angles BAE is equal to angle CAE by congruency. Then again, AE is common, right? AE is common. AE is common. So again, by the case of SAS, these two sides are equal. A is common to both these two triangles, and this is the included angle. The included angle is same. So by the case of SAS, triangle BAE is congruent with triangle CAE. Next, they have asked us to prove that AE and BC are perpendicular to each other. Now we have found that these two triangles are congruent. So the side BC, BE is equal to side EC. By the congruency of these two triangles. So BE equals to EC by the theory that this line over here bisects BC and also bisects the angle. AE is the perpendicular bisector of BC. This bisector over here bisects the angle also bisects bisects the angle BAC, as these two are equal, also bisects BC. Therefore, AE is definitely the perpendicular bisector of BC. So we can write the statement that BAE is equal to EAC. We have stated it already, CAE. And we can say that BE equals to EC by their congruency. Then, therefore, AE is the perpendicular bisector of BC. Then AE is perpendicular to AE and BC are perpendicular to each other.